Hello everyone. I just wanted to make a quick video because I didn't get to finish the lesson with you guys in class. So I wanted you to be able to do your homework problems, which I originally told you guys to skip, but I still want you guys to do your homeworks. I think I said 3, 6, and 7. But it's still important for you guys to do them. Yeah, so I had originally told you guys to skip 3, 6, and 7, but I'm going to show you guys how to do it in today's video, okay? So whenever you have something like this, the square root of x minus 3 times square root of x plus 4, you have square root of x's on the binomials. You need to distribute just like you normally would with a normal radical, like a root 2 or root 3. You do the same thing. So you're going to take the square root of x and you're going to distribute it. So square root of x times the square root of x is going to give you the square root of x squared. And then we'll simplify that in a second. But then let's continue. Square root of x times 4, that's a number times a radical. So you just attach them together. That's plus 4 times the square root of x. And then we're going to do the same thing with the negative 3. So if I distribute the negative 3, that's negative 3 times root x. And then negative 3 times 4, that's negative times a positive is negative. That's going to give me negative 12. And then I want to combine like terms and then see if anything cancels. So if you notice, I have the square root and the squared right here. So then this ends up actually canceling. So you just get x. And then these two terms in the middle, 4 root x minus 3 root x, those are liked terms because they're both root x's. So I can just add 4 plus a negative 3 is going to give me 1. 4 minus 3 is 1. So this is just going to be plus square root of x or 1 root x, but you don't have to put the 1 there. And then just drop that negative 12. Notice the difference between this one. Normally, we put the number in the front. Like these, we put the number in the front. Let me see if I find another one. Normally, again, we put the number in the front. But whenever we have variables like x's, the number goes at the end. Just like when we write like x squared plus 2x plus 3, the constant goes at the end. Same thing. This negative 12 is going to go at the end. So then that's going to be your answer there. Okay? I want to go ahead and do another example. Just so you can see another one. So same thing. I'm going to take that root x. So this is root x plus 8 times root x plus 2. And you're going to distribute root x times root x is going to be the root of x squared. And then root x times 2. You can't multiply the 2 and the x, so just attach them together. That's 2 root x. And then distribute your positive 8. So 8 times root x is positive 8 root x. And then 8 times 2 is the number times the number, so that's just 16. And then you want to combine your liked terms and get rid of stuff. So this in the beginning right here, square root of x squared, the square root and the squared cancels. So you're just left with x. And then these two right here again, let me use a different color because it kind of looks like the red. So those two in the middle, that's root x and a root x, they're liked terms, so I can add the numbers together. 2 plus 8 is going to give me 10. Square root of x's. And then just bring down that plus 16, and again you leave it like that because anytime you have variables, the constant goes at the end. So that's actually your final solution there. Okay, on the homework there is another example that I believe, I'm not 100% sure what it is, but it's like root x plus 3 maybe, I don't know, squared. So remember that this squared right here basically tells you that you have 2 of the same one. So you want to do root x plus 3 times root x plus 3. And then you do the same thing. You're going to take the root x and you're going to distribute. And then you'll take the 3 and distribute. Same like you did for the last two examples. Okay? And that's pretty much it. I just wanted to make sure that you know how to do your homework, okay? All right. See you guys next time.